Now the interval containing the values of the integral 1 to 5 product of the continuous factors x minus 1 into x minus 2 into x minus 3 into x minus 4 into x minus 5 dx, right? So we need to find this integral value, definite integral value, and see which of these intervals contains the required value. Let's consider the given integral as I 1 to 5 product of continuous factors x minus 1 into x minus 2 into x minus 3 into x minus 4 into x minus 5 dx, right? Now as you look at from 1 to 5 and all the continuous products from x minus 1, x minus 2, x minus 3, 4 and x minus 5 are included in this. So why don't we use the result integral a to b f of x dx will be equal to between the same limits integral a to b f of a plus b minus x dx, right? One of the well-known results in definite integrals, a very important property. So what happens to the limit when we replace x with 5 plus 1 minus x? This value of the limit becomes 1 to 5. Yes, it would be 6 minus x minus 1 into 6 minus x minus 2 into 6 minus x minus 3 into 6 minus x minus 4 into 6 minus x minus 5 dx, right? Now by this substitution, if you observe, all the terms of the given expression are again formed here with all with a minus sign difference. So this is integral 1 to 5. What is the first factor? It is 5 minus x into, now here it is 6 minus 2 minus x, so 4 minus x into 3 minus x into 2 minus x into 1 minus x dx. If you look at, there are 5 such factors, each with a minus difference. This is minus of integral 1 to 5 back to the same product as x minus 1 into x minus 2 into x minus 3 into x minus 4 into x minus 5 dx. But this value of integral 1 to 5 x minus 1 into x minus 2 into x minus 3 x minus 4 x minus 5 is the original I given. So what did we get? When we started finding the value of I, the same integral on replacement with integral a to b f of x as f of a plus b minus x is integral between a to b. We got the value to be minus I. So when we add this, we get I as minus I or 2I is 0. So what would be the value of I? Yes, the value for I becomes 0. And which of these following intervals would contain this I value as 0? Yes, as the second integral is between open interval 0 to pi by 2, I cannot be 0, cannot be there in this. As the third case has minus pi by 2 to 0, but 0 open interval, 0 is not also included here. As the last interval starts from pi by 8, 0 is not included. So the only interval which contains the 0 value is the option A. Now interestingly, the same problem can also be solved in a different method as change of variables. Let's consider I as the given integral 1 to 5 x minus 1 into x minus 2 into x minus 3 into x minus 4 into x minus 5 dx. Now as a mean term of all these factors, let's take t as x minus 3. Now when we consider t as x minus 3, what would be dt here? Dt would be same as dx. Not only this, in the integral even the limits changes. As x tends to 1, the value of t would become 1 minus 3, that is t becomes minus 2. And similarly, as the upper limit extends to 5, the value of the new variable t becomes 5 minus 3, that is plus 2. Then how will be the integral in the changed parameter? How will be the given integral in the changed variable t? Now it is integral minus 2 to 2, and now this factor x minus 1 becomes t plus 3 minus 1 into x minus 2 becomes t plus 3 minus 2, x minus 3 is the t, x minus 4 is t plus 3 minus 4, and x minus 5 factor is t plus 3 minus 5, and the value of dx is equal to dt. Now look at this integral here. This is integral minus 2 to 2 t plus 2 into t plus 1 into the middle term is t, and this is t minus 1 into t minus 2 dt. Now if you rearrange these factors and multiply, this is minus 2 to 2 t times t square minus 1 into t square minus 4 dt, right? Yes. as you look at the function inside this, t into t square minus 1 into t square minus 4, and the integral is between minus 2 to 2. And whenever the integral is between minus a to a, first we will be checking whether the function inside the integral is an even or odd. So from minus a to a f of x dx is, the value of this integral depends on the nature of f of x. This would be integral 0 to a f of x dx if f of x is even, and we also have this result is 0 if the function f of x is odd. Remember? So what will happen if you observe this? Because the function here, that is f of t equal to t into t square minus 1 into t square minus 4 is an odd function, right? Then by simple application of this result, this integral value between minus 2 to 2 will become 0, right? So this is the same as the value of I we calculated in the previous method, but here we have used a different result, that a to b f of x dx is integral a to b f of a plus b minus x, and here we have changed the variable and used the characterization of the function's oddness. Therefore the limits between minus a to a becomes 0, right?